Yeah, good afternoon, everyone. Thanks to Dr. Nagesh for delivering such an insightful session on how AI could be useful specifically for vehicular application. So definitely, this will help me set the stage for some of the examples I also talk about. Yeah. So I come from an interdisciplinary background. Okay. So I will talk about how you can actually integrate AI in engineering systems. So a very quick show of hands, how many of you are from an engineering background here? All of you? Okay. So I see a lot of hands going up. I believe a lot of you have also joined online and you can relate to what I will talk about. So basically my talk will be divided into three parts. I will start talking about some of the key trends that we have observed in the area of integrating AI in engineering systems. And we will also try to find out what are the key learnings that we can sort of take away from here. And as we plan to integrate AI in our systems, how can we go about it? And finally, we will talk about what could be some very interesting resources for academicians such as yours to continue in your journey towards integrating AI in engineering systems. So, we are all familiar with engineering systems, right? Any system that takes us from point to point B uses energy, or just something that transmits or receives information can be classified as an engineering system. And very correctly, as it has been emphasized in the earlier sessions, if you look at the different sort of uh, applications of engineering in today's world, you will find that most of them are firstly interdisciplinary, and secondly, they have become more and more complex with time, right? So this gives us a very important thing to think about, that how can we benefit from advances in AI and how leveraging AI can give us some benefits in an engineering system. So first thing I did was I tried to find out what could be some of the motivating factors that lead us to sort of look at integrating AI in an engineering system. So very quickly, I actually tried to leverage AI only. So if I just look at what Copilot talks about, I just ask it, can you give me a compelling reason that why should I integrate AI with an engineering system? Very interestingly, it throws up an answer. Some of the keywords is something we have heard over the past 2 days, right? If you look at here, usage of AI will help me with productivity gains, and it will allow me to work with enhanced systems. And as a person, as an engineer, I can focus on high-value tasks rather than repetitive tasks. So I cross-checked this with what some of the top universities have to say. So I took a quote from Johns Hopkins University, and very interestingly, the keywords actually match. So they are also talking about that AI will help me increase my productivity, and then it will help me come up with innovative solutions, right? So there is a very strong motivation for us to look at utilizing AI possibility to enhance or come up with very good solutions. So now let's look at some use cases to understand this in more detail. Okay. So given that I will talk about engineering systems, I have put a diagram here explaining how an engineering system sort of is simulated. So you can very quickly identify, I'm taking the example of, let's say, vehicle. So in a vehicle, you will have the physics of the vehicle that you have to take into account very carefully. Once your vehicle equation is all there, you have designed it carefully, then the next most important part is the controls. So integrating controls with the plant body of the vehicle, once you have done that, then you can also look at things like perception and sensing, which, as it was mentioned, is very important in today's world, that we should be able to perceive where the vehicle is moving about. So when you have a system like this, there are many ways you can actually leverage AI as a part of the engineering system. Okay. So this is sort of a template I will take. And then I will take some examples to explain how people have leveraged AI for this sort of applications. So the first example that I will use talks about reinforcement learning. Okay. It is mostly related to applications in the controls domain. Okay. It's a sophisticated form of controls. Later on, I will look at something called a reduced order model. Okay, I will explain what that is later, and then finally we will look at one more use case of a virtual sensor. Okay. So let me take the first example of how people have leveraged an AI method like reinforcement learning for solving an important engineering challenge. Okay. So given that this is sort of the, I think, one of the last talks of the session, I thought I will end with something heavy. So looking at the picture, are you able to identify what sort of application could this be related to? So it's an application related to a black hole. Okay. So nowadays, if you look at the frontiers of physics, one of the key challenges they are working on is how to detect black holes, specifically from the gravitation signatures, right? So the way they do it is that they have a setup that looks something like this. So this is a photo that has been taken from one of the very important centers called the Max Planck Institute for Gravitational Studies. So they have a huge field where there are two arms that go 4 kilometers long. And basically, they take a laser light. They pass the laser light through both the arms. And then there is an interference that happens. And from that, if there is a gravitational wave, one of the light beams, laser beams, will travel a greater distance compared to the others. So you will have an interference pattern. And from there, you find out the signature of the gravitational wave. Now, what could be the challenge here? So a very important challenge here is that when you work with such systems, firstly, they are very sensitive. And they have a lot of mirrors which are there. Okay. By the way, I have taken the example of Max Planck Institute, but in India, we are working on a very similar problem. So some of the key Indian institutes are actually working on coming up with a mirror and laser system to detect gravitational waves. So this sort of systems, they have to be controlled and aligned very accurately. And our knowledge or our capabilities in doing this is actually not that great. Okay. So what they have done is that they have actually come up with reinforcement learning, where they look at the video images. So here they get the video image, the interference patterns. And from the interference patterns, they have an AI that actually identifies the misalignment of the mirrors. And once this AI corrects that, once the AI corrects the signals, what they have found is that the accuracy of this sort of system is better than what humans have been able to achieve. Right? If you look at the image here, the horizon distance that you can sort of accurately capture with an AI technique, like reinforcement learning, is better than what humans have been able to do. So this is one example of how AI can enhance an engineering application. What other advantage do you think is possible for a method like this? So the other major advantage that you have is that this sort of engineering system, these are multi-billion-dollar equipment, right? You cannot just go and test any algorithm there. So you, in simulation, you can actually try out your algorithms, various different algorithms, train your model correctly, and then once you are happy with the result, then you can deploy it to a real system and test what sort of accuracy you are getting. So this is exactly what the users had to also say, that they were able to perform a lot of tests just with simulation before deploying it to a real system. Right? So in the very beginning, this emphasis was already there, right? That you should always, Mr. Salini said that you should experiment, make errors, and from there figure out what is the best solution. So simulation allows you to do things at a very cheaper cost, firstly, and then you can leverage those results to come up with systems that work without any error. The second one that I will talk about is called a reduced order model. How is this important? So in today's world, there are two conflicting sort of requirements that come up. So I want to understand very accurately how a system works. But at the same time, I want to integrate it with the system and test out its performance. So what you have here is a jet engine turbine model. So initially, what you can do here is that you can actually take and run it as a high definition model, where you capture all the different physics which are there. There is a high fidelity model for that. This could be important to understand how that component actually functions for a particular application. But then we have an AI model, which is a neural state space model. So using this model, we can also get result, but in terms of accuracy, this might not be that great. Okay. But why is the benefit there? What is the benefit of going for a reduced order model where my accuracy is lacking a bit? The main advantage is if you look at the time, stop time, it's 7,000 seconds. So it's a simulation that learns for a pretty long period of time. Okay. So if it's a system level model and if you want to get results fast, then you have to take the help of models which are not that high definition, but which give comparatively accurate answers. So here we were able to run this simulation, get the result very fast, and that gives, so these models we can integrate and test at a system level. And that also gives me a very good understanding of how they perform at a system level. So nowadays, the emphasis is that we should understand engineering systems as the component level, but also we should understand how they function at a system level. Okay. Third trend. I'm not sure if how many of you have heard it. It's called virtual sensor. So if you look at any application like a mobile phone or an electric car, one thing that is common between both of them is that you need to predict the state of charge of the battery very correctly. Why? We are users of battery technology, right? When the charge falls, our anxiety rises. Right? So nowadays, there are so many different methods by which you can do that. One way is to use AI-based methods, where you have an AI model, you train it with some data, and then you look at what sort of prediction it makes. Okay. So overall, the entire system might look something like this, where you have a battery, you have to design the entire plant model, and controlling the output of the battery, we have a battery management system. So AI here is a small part of the entire system, right? We have developed an AI model. It is part of an entire system. And what we want to understand is how accurately this sort of predicts the state of charge of the battery. So by the way, why are we trying to use a virtual sensor? You actually cannot sense the state of charge of a battery, right? There is no sensor you can put inside. So the best thing that you can do is to measure it virtually by looking at the other parameters which you can measure. So all you need to do in MATLAB is that you have to train the algorithm. So let's say either I train the algorithm in MATLAB, or many of you have access to some of the best world-renowned models from different frameworks. Okay, it could be a PyTorch model, it could be a TensorFlow model, or a Python model. So you can bring any of the best available models into the MATLAB environment and use MATLAB as an environment to prototype the entire system. So you can bring the algorithm into MATLAB, you can integrate with the engineering system, and simulate and see how well it performs. So I'll just showcase the answer. So what are the benefits of a system like this? Why bring it into the MATLAB platform and do all those things? So the best benefit is that we can test whether all the requirements at a system level are met or not, right? AI, you are building it quite well, but the system might have a very different requirement. Your car has to achieve a certain range. How can you correlate it with the battery state of charge? That is where you have to integrate the model with the system and test. Okay, so there are so many different scenarios which you need to sort of identify and see whether your requirements are met. This is what MATLAB will allow you to do. The next thing is that how are they going to be tested? So here you can actually create test scenarios and automate them. So you can directly just create a model which will automate the entire tests, and you can see all the result at one place. And the final benefit is that everything is traceable. So you are able to see for any given algorithm that which part of the algorithm is contributing to the system results. So you are able to trace the feature with the code. And who is using it? So many of the automotive companies have started working in this area. What they are trying to figure out is that are approaches like this a suitable way to go about? So here I have a user story from KPIT where they were able to take this AI model and integrate with an entire EV system model. And some of the important benefits that they found is something that we can correlate with. So they were able to estimate the SOC at a system level with a system level performance. And finally, they were also able to integrate it with hardware and also see that whatever they were thinking, whether it was matching in the hardware also or not, right? So simulation shouldn't just stay in the simulation world, it should translate to certain hardware related performance, okay? Finally, the fourth, I would say point is very important, and this is important for all of you, right? So Dr. Nagesh said that you should actually look at how these sort of systems perform, right? So, and one important way of looking is also to see how it performs in a real world, right? So, deploying an AI algorithm is also a very key part of the entire process of integrating an AI into the whole engineering system. And there could be so many different systems. It could be something like a server. It could be something like a edge device, right? They will all have different sort of capabilities and memory requirements. So what we can do is that you do not have to hand code everything. You can use automatic code generation packages that will take your algorithm and it can convert it to different sort of hardware. It can deploy it to different sort of hardware. Same code, different hardware. And all of it just by going 2-3 steps. So as modern cars grow in complexity and they have more and more lines of code, this sort of workflows will introduce the students to the idea about how to prototype this sort of algorithms with respect to an engineering system, right? Today, as students, they might be working with low-cost hardware like Arduino. Tomorrow, they might be working with a higher-end hardware like, let's say, Jetson, or something even better than that. They might work with FPGAs. So they should know what is the proper way to prototype this sort of algorithms. So I have one example. Here you can see, this is from a university in Hong Kong. It's called AS3. So what they have done is they have created digital twin. So there is a physical twin, and based on the sensor data, using AI, they are able to find where those components are, which it is sort of trying to connect to. And the important part of this is that they actually used the deployment workflows to use an NVIDIA CUDA container to deploy with an NVIDIA DGX station. So this is an example that is very relevant for Edu, I would say. Over the last couple of years, I have found a lot of researchers who are focusing in this area. So they are trying to create digital twins of, I have seen wind turbines, I have seen digital twin of batteries, people are trying to create digital twin of cars. So a lot more application is what we are seeing from academia in this particular area. And very interestingly, it very closely correlates to what the physical twin is doing. So this is what a digital twin does. But is this what just researchers are doing? So taking a cue from Dr. Nagesh, I will just show what students are doing. Okay. So there is a team specifically from Italy. So they have a team called Dynamic PRC. What they have done is very interesting. So they have created a car. So this is a virtual model of the car they have created based on the components they have used, and they have a test track, and they are doing a very interesting maneuver called the skid pad maneuver. And they have taken this car and run it on the simulation. But not just that, they had built a real car from the data and taken it on the test track. And once they overlap the simulation on top of the real car, they found that the match was actually quite close. So not just researchers, actually students are also leveraging and they're finding benefit to these sort of workflows, right? You do not have to build a physical car. All you need to do is build a virtual prototype and do most of the tests using simulation, right? So that when you go to the test track, it actually performs like you have intended it to. Okay. Finally, what will take an application that you have built to the wide consumer market? Okay. Many of us use actually different engineering systems and we depend upon it like anything. Just to give you a hint, automotive, aerospace, medical devices. How comfortable are we in embracing an AI algorithm in this sort of applications? How many of you are comfortable in embracing AI in this sort of applications? Why? So I don't see any hands raised, very interestingly. Why? Because we are not sure whether to trust the system or not, right? So nowadays, a very important part of the whole thing is the focus has come into how to go about doing the regulation, how to do the certification. These are very important part of all these safety critical industries. So to ensure that you are able to take AI, integrated in an engineering system and get it certified, you have to actually modify your workflow. You have to bring in certain workflows which will address the explainability of the AI model. People should understand what the AI model is actually doing. It's not going to be a black box. You have to have certain methods to ensure that the code doesn't have any hidden errors, right? So there are workflows that address this. I'm not going into the details of that, but definitely these are areas in which you can leverage MATLAB and Simulink. So we have a toolbox called Deep Learning Advisor that will advise and allow you to generate code that can help you go ahead with the certification process. Okay. So this is a summary of what we have observed as key trends in the different applications seen so far, right? So some of the key things are that integrating AI as a part of an engineering system is not that complex, although the systems that you work are going to be very complex. Second thing is that there are vertical workflows. Vertical workflows means very specialized workflows. You could be working in robotics, you could be working on UAVs. So you need very good examples to get started. So at MathWorks, we have created examples that take you end to end, starting from the very basic requirement to the deployment part of it. Okay. Third important thing is that you can actually use this as a great platform to sort of integrate with different hardwares. So no matter how comfortable you are, what you can do is that you can take the best available models, bring it into the environment, and use it as a platform to deploy. And lastly, given that there is a lot of interest in the AI space and a lot of good models from the open source frameworks, you can actually bring them into the MATLAB environment and use them. So now this brings into what is there for the academicians. Okay. So I will start first by showing something on the generative AI side, and then I will go to the resources that you can use. Okay. So we now have, on generative AI based, we have the AI chat playground. You can just write using text that what you intend to do. You will get the code. There is a small place where you can run this code. Okay, and you can see the output then and there. And it will, to take the conversation step by step further, it will also give you cues that should I make this change in the axis? Should I change the font size? Okay, and then you can just run it and see what change is happening, right? Because generative AI, as multiple mentions were there, they can hallucinate. So the best way you can actually test out your code is actually to run it. So here we are just running it and trying to see what sort of results we are getting. And then the possibilities are endless. You can actually play with the same code, modify it, and do different sort of results you can get, right? So this is a pretty good place not just to test out your ideas or get code, but from academicians, what we have seen is this is also a great place for academicians also to generate assignments, right? For student assignments, you have to create that entire assignment, run it at your end, see whether it runs or not. And there are so many assignments to do. So this is a great productivity tool for faculties such as yours. You can take the code and create it as a reference solution is something known as MATLAB grader. And then take that code and grade multiple students together at one go. Okay? So now, where to get the students started? So, any engineering discipline over a 4-year period has a number of key courses where AI plays a very important part. If you look at the diagram where we have taken something from AICT, what we have found that some of the advanced courses in the 3rd year are something which you need to actually focus on because they allow you, the applications itself dictate that AI could be useful to integrate in those courses. Okay. But the important thing is that if the students are not introduced to some of the fundamentals, then they will actually use AI just like a tool without understanding, right? They will take AI, they will try to solve a problem, but they will not understand what that problem actually means and what the solution actually also means. So there have been instances where I've seen, specifically for hackathons and all, that students have taken help from something like a chat GPT and they have developed an entire algorithm and they are able to show results. But they actually do not understand what those algorithms actually do. So to address this particular gap, skill gap, what we have done is that we have identified certain courses and we have built content that will allow you to teach the basic fundamentals to the students. Okay? So you will hear a bit more about this tomorrow when my colleague, Mrs. Nikita Pinto, who is the AI liaison for the entire Asia region in MathWorks, she will talk more about these courses, but I will show you a few snippets out of it. So self-paced courses is what we have. Yesterday, Dr. Kannan from IIT Bombay was mentioning, right, that students find a lot of benefit when they actually try out things at their end. So MathWorks was a company which actually believed in self-paced course, and over the period of time, we have come up with a lot of different self-paced courses. Some of the ones that you see here are introductory ones, okay? And if you just look here, we see something like deep learning on-ramp. We see something like machine learning on-ramp. Sorry, just a moment. Okay. So those are courses where you actually can get started teaching the student the basic of AI. So once the students are comfortable and they run a few things, then we can take them to advanced courses. So we also have something known as modular curriculum, where over a certain number of hours, here we have something like overall 12 to 20 hours as the lab exercises. So this could be something that the students can also do as integrated part of the particular course. Okay, it's modular in nature, so you can very easily integrate with your curriculum. You can take sections of it. Whichever concept the student finds challenging, you can very easily take the scripts, and these are meant to aid their learning process. So to give you an idea, important mathematical concepts, specifically engineering, something like what does a particular algorithm which does classification actually work, how it actually finds patterns in data, how do convolution networks work, how a particular layer identifies certain feature from the data based on mathematical algorithms. So we go into the mathematics, students are able to look into the mathematics and visualize. So the third one is where you see how a gradient descent algorithm works, which is something very fundamental to training an AI model. And not just in 2D, you can see also in 3D how it actually identifies the minima of a particular cost function. So once the basics are very clear, later on in the third semesters, when students do advanced courses specifically linked to signal processing or in other domains also, so then they can actually understand how these algorithms play a role in identifying the outcome. Lastly, a very key thing that we have heard from academicians such as yours is that, okay, my student has learned all these things. Where should he test it out? So many of the students do projects, right? And at MathWorks, they come to us and they ask us that, can you suggest some project which is industry relevant? So we have come up with a repository of projects that a student can actually take. So there is a page called MATLAB and Simulink Challenge projects, which are meant to challenge students. Okay. So we have collated a list of not just projects here, but we have collated a list which actually students can take up and do at their end. Let me just show you a snippet of that. Okay. How many of you are familiar with this challenge projects? Okay, this is quite new, right? So when you do a challenge project, anyone can do it. And if you complete, you get a certificate from MathWorks. Okay. So projects, there are challenges also, by the way, competitions also, but projects are given according to technology areas. So if you look into AI, you see there is a lot of relevant projects starting from applications in the medical domain, applications in the energy domain, fault detection, specifically could be interesting to people working in the electrical domain. So all of these projects are given. And the main biggest challenge for a project is that how to take the first step. So here if you see, the first step is given for the student. So there is a project description, some motivation, and how to get started. So once you get started, there is background material to read through, and then they are suggested the directions that they can take. And this is all mentored. So if any student has a question, they can reach out, ask their questions, and somebody from MathWorks will reply to that. Okay. So this is something that can really help educators such as yours. It will make your task a bit easier. And once they finish the project, they will get a certificate from MathWorks, and very good solutions also get featured in our blogs. So they will get a lot of views. They will be able to share their stories with a lot of people. Okay. So with this, I will show you a very interesting story that I have found from the AI domain. Okay. So this is taken from Istanbul Technical University, where a director was teaching a controls course. So he's a director, he's a very busy person. The main challenge was that he liked to teach using traditional technologies with a blackboard and a pen, right? Many of us are familiar with this thing, right? We like to teach using blackboard, pen, showing them the exact steps, but we also want them to go back and explore more using simulation. So here, the faculty was very busy, but he taught the students some basic. The students were familiar with basics of AI. So they went back and they came up with a very interesting solution to help the professor. Okay. So they took all the things that he was making on the board and they created an algorithm to identify. So here, what you see here, you see a transfer function. So they created a particular algorithm that is able to take in these images and identify the transfer function based on the constituents. And once identified, they were able to convert it to a MATLAB function. Okay. So later on, from board to code is what I say this user story is. So later on, this is how the entire application looked like. So the faculty would write something on the board. So sorry for the loss, the clarity, but you can see what he's actually doing. He's writing the entire control thing on the board. And you can see that directly it is getting translated to a Simulink transfer function, right? So in this way, the faculty was able to inspire his students, and his students were able to come up with innovative solution to help him improve the entire teaching process, right? So with this, I will try to conclude today's talk. If you have any questions, I am happy to take it.
We have just experienced an incredibly insightful session on integrating artificial intelligence in engineering systems, delivered by none other than Dr. DebanandSingdeo. Your talk today has not only provided a fresh perspective on integrating AI into engineering systems, but also highlighted practical approaches and transformative potential. On behalf of everyone present here, I extend our heartfelt thanks for this enlightening keynote. We now open the floor for a Q&A session. If you have any questions for Dr. Singdeo, please raise your hand and we'll bring a microphone to you. Kindly keep your questions brief and focused on today's topic. And also, the session is streaming online and around 300 delegates are watching.
Sir, this is on application of engineering solutions to some physics problems. I have a doubt regarding the chaotic theory of butterfly effect. When a butterfly flutters in Trivandrum, there could be a tornado in Brazil, like that. So how we can simulate that chaotic state of butterfly flutter to tornado? By calculus, what I gather is that it is by differential calculus. So please explain such episodes of scientific theories like that. You mentioned about black hole. The cosmology problem in cosmology is that it can't be simulated because astronomical amounts of data is there, means exponential data is there. The problem is integrating that data. That is a major problem. So how will you simulate the Big Bang as an engineering solution using generative AI? Can you simulate a black hole or a Big Bang with a generative AI?
Okay. Interesting questions. So first one, as I can understand, it's linked to the chaos theory, right? Like a butterfly's wings flutter in a place, how will it sort of cause any other event in a different place? So the important thing to model any given system is either you should know the physical laws that govern the system. That is the way people have done work like this so far. And the other way could be using a data-driven system. So if you are able to capture, let's say you know the physical laws, then you can model the physical laws and get. But I can very clearly understand in some cases, you might not be actually able to model the physical laws directly. So in those cases, you have to have some sort of data. So for a butterfly moving about, I was recently reading a particular story about how people are trying to model it. By the way, butterfly wings, it's known as one of the problems where you have a flying object with wings which are quite big, right? The loading is actually very less. So when it moves about, it actually causes a certain turbulent flow. It's not something that you can directly, I would say, approach just by using equations. It's not easy because the surface itself morphs as it moves about. So what people are doing now is that they are taking photographs of how the butterfly is moving about with very fast cameras. And then they are coming up with AI model based on the data, which tries to predict how the wind flows, what path the butterfly will take. So people have started working on it. Actually, MathWorks also has a user story in this area. So if you are very interested, I can share it with you.
Sir, there another question is regarding AI singularity.
Sorry?
Singularity in AI.
Singularity in AI, okay.
Ray Kurzweil predicts that a stage will come around 2050, then the generative AI or quantum generative AI will outsmart human brain. So can we predict in advance or simulate such a state of AI singularity now, today? What would be 2050 generative AI will be like? Can we simulate it?
Sorry, predict singularity?
Singularity means a point where there is no physics law applies there. So
okay.
that means is that with the ChatGPT, a time will come when emergent behavior.
Got it. So what Sir is asking is that there are scenarios which, from physics, we know that there could be no physical law applicable to such something like that, because there is actually no physical object you can quantify. Because, for an example, like a black hole event, light might not escape, right? So how can you work with that? But interestingly, here also, although light might not escape, a black hole actually behaves in line with the law of conservation of entropy. So from that, people try to back deduce and try to find out what is actually happening. So generative AI might not be at a place as of now to tackle these sort of questions. But they say, see, it's an AI algorithm ultimately. It doesn't exactly, as of now, understand physical laws. So if you look at some of the works that are happening in the very bigger, very frontier labs across the world, what they are doing is that they are trying to see how you can make an AI understand physical laws. How can you do that? The AI can only understand if it was a physical person, like gravity.
Sir, I will tell you one thing.
Yes.
In this context, what is asked is, I am reminded of John Searle, the American philosopher who devised the Chinese room experiment.
I understand.
The Chinese room experiment.
We better not go into philosophy part because philosophy can say anything and have arguments for and against both of that. But definitely, AI right now is not at a place to look at that area because it doesn't understand physical laws. People are looking at that area, how to do that, okay? So definitely I would love to talk more with you, but given the time constraint, maybe whatever you suggest from your end we can do, yeah. And thanks a lot for people joining here. It's the end of the day. I can see still some excitement on your faces. So this is something I will take away with me. So I'm very happy to have all of you here joining me in this event. Thanks to the organizers and thanks to the entire team supporting here. They have been very gracious throughout the whole event, taking care of us. So thanks a lot to all of you and looking forward to really exciting times here in the future. Thank you all.
Thank you, Dr. Singdeo, for addressing these questions with such clarity and depth. Your response have added immense value to today's discussion.
As a token of our appreciation, may I now invite Sri Sajan Jaya, Principal College of Applied Science, Airur, to present a memento to Dr. DebanandSingdeo. Dr. Singdeo, this is a small gesture to express our gratitude for your valuable contribution today and for sharing your expertise with us.